Let us see one more question for AP Physics. So this question says a person push a pushes a box across a horizontal surface. So let us make a diagram. So this is our horizontal surface and there is a box, right? And there is a person who is pushing this box, right? At a constant speed of 0.5 meter per second. So its speed is constant and it is 0.5 meters per second, right? The box has a mass of 40 kg, so it has a mass of 40 kg, and the coefficient of sliding friction, or you can say the kinetic friction coefficient, that is the mu k kinetic friction or sliding friction, is 0.25. It's given. Now we have to find the power supplied to the box by this person. So how much power is being supplied by that person to this box? So this is our question. So let us try to solve it. So first of all, if you try to understand that power, what is the power? So power is work done upon time. So it's work done per unit time. So what is the work done? So work done is basically force dot displacement upon time. Now what's the force? How much force this person is applying? So let us try to find. So how much force, or we can say what kind of force is applicable here? So we can make a free body diagram, or you can say we can draw all the forces on this body. So if you try to visualize, so this is the F applied, and since there is a sliding friction available, so it means there should be a frictional force also, since motion is going in the forward direction, so its frictional force will be applicable in the reverse direction on this block, right, or box. So when we will try to write its net force, so we can write F minus this frictional force F should be equal to mass into acceleration. That's the Newton's law. Net force is equal to mass into acceleration. And since its speed is constant, you can say speed is constant, it means acceleration will be zero. This is a very important. Since its speed is constant, direction is same, so overall velocity is constant, right? It is going in the same direction in a horizontal surface. Please take care of this word. So there is no change in the direction as well. Magnitude is already constant, so overall velocity is constant. We can say velocity is also constant, so acceleration will be zero. So this can be F minus F will be 0. So it means applied force will be equals to this frictional force, right? And what will be this frictional force? You can write this frictional force as mu times of n. What is the mu? We have given mu is 0.25, and what's the normal force? That's the mg. We can apply, we can put the values basically. So m is 40 kg, and let us take the value of g as 10. So this will be 100 Newton. So it means the applied force is equals to 100 Newton. Now let us try to find its work done. So it's 100 Newton multiplied by how much distance, we have to take. See, its speed is 0.5 meter per second. If we take the time as 1 second, if we take the time as 1 second, it means in 1 second this block is going to move 0.5 meter, isn't it? If we consider the time for 1 second, right? So the distance moved will be 0.5 meters. So you can say this is in Newton, this is in meter. And if you think about the cos theta, because what's the F dot D? It's F magnitude, it's D magnitude, and it's cos theta. So since force is in the same direction, displacement is in the same direction, so the theta will be 0, so you can apply cos 0 here. So let us try to calculate this. So this will be 100 into 0.5 into 1 upon 1, and this much of watt. So when you solve it, you will get 50 watt as the answer. So its correct answer will be 50 watt. Let us see its options. So according to options, its correct answer will be C, 50 watt. Okay students, so I hope you have understood this question. So if you have understood this question, please like this video, share this video and subscribe this channel. Thank you. Thanks for watching.